Section 1.5b is about simplifying expressions, and specifically simplifying expressions that involve the distributive property that we learned in the last video. Here we have our first example, 5 times the quantity g minus 9. If you remember, I have to take this 5 and I have to distribute it, which means multiply it by each term inside the parentheses. So in this case, 5 times 9, and then simplify. 5 times g is 5g, and 5 times 9 is 45. Also over here you see a 3 that's being multiplied by a polynomial. We have to multiply the 3 times each term. So in this case we'll distribute 3 times. So 3 times 2x squared plus 3 times 4x, and then minus 3 times 1, 6x squared plus 12x minus 3. So that's a little review on the distributive property. Now we'll talk about some definitions so that we can speak intelligently about the different things we're going to see in this section. The first definition of the word called term. A term is a number, a variable, or the product or quotient of numbers and variables. So a term is pretty much anything. The number 3 is a term. Negative 6 is a term. It could also be a variable like x or a or h. It could also be the product or quotient of numbers and variables. 2x is a term. Negative 4z is a term. 6 over h, that's a term. If you look at something like a 3x plus 2, that's not a term, but the 3x is, and so is the 2. So another interesting thing about terms is that terms are the pieces of an expression that come between the pluses and minus signs. Just something else for you to look at. So all these are examples of terms. Now, what makes a term a like term? Well, a like term are two terms that contain exactly the same variables, and the exponents have to match. So if I do something like 2x squared and negative 3x squared, those are like terms because their variables are the same, even the exponents. So they're like terms. I don't care about the 2 and the negative 3 in this case. They're still alike. If I have 4h and 6h squared, those are not like terms because one of them is an h and one of them is an h squared. If I delete the squared, now 4h and 6h are like terms. So it has nothing to do with the number in front, but it has everything to do with the letter and the variable that goes with the letter. That's what makes something a like term or not. And then the third word here is a coefficient. The coefficient is the numerical factor of a term. So in 9x, the numerical factor is a 9. So we say the coefficient of this term is a 9. Coefficient of this term, negative 5y, the coefficient is negative 5. How about negative y? What's the coefficient there? Well, the number that's in front of the y is a negative something, and when there's nothing there, we assume that there's a number 1. So in this case, the coefficient of this term is a negative 1. A lot of people forget that. So the coefficient is the the coefficient is the numerical portion, or the numerical factor of a term. Okay, so what do we do now that we know what those things are? Well, here's what we do. We have two terms, and these both are like terms. We have a 15x and an 18x. And I like to put boxes around like terms to show that I'm going to combine them. Well, 15x plus 18x, when you combine them together, it's like saying 15 pencils plus 18 pencils is how many pencils? Well, that's 33 pencils. Same thing here. 15x plus 18x come together to be 33x. Notice it's not 33x squared. We didn't multiply the letters. We just added them together. Over here, do you see any like terms based on our definition? Well, I do. I see a positive 3n squared, and I see a positive 9n squared. I like to include the sign in front of the coefficient because that tells us whether we're going to add or subtract. So what do we have here? We have 10n, and then what's positive 3 plus positive 9? That's a positive 12n squared. So when you collect like terms, all you do is add or subtract the coefficients. The letters don't change at all. They just come along for the ride. Here we have a couple more definitions for us. The first one is equivalent expressions. Those are expressions that are equal. So 5x plus 3x, and if we say that equals 8x, then equivalent expressions are the 5x plus 3x, that's equivalent to 8x, because they're both expressions and they're the same. It's that simple. If two expressions are the same thing, we call them equivalent. Simplest form is the word that we give when expressions exist with no like terms or parentheses. So if you're asked to simplify an expression, make sure that it has no like terms, and you can do that by collecting like terms like we learned in the last video, and then it has no parentheses. And if you remember, one way that you can get rid of parentheses is by doing the distributive property. So you may be asked to distribute something like this 3, and when you do that, you can help get rid of parentheses, therefore simplifying an expression. In these examples, we're going to use the distributive property to simplify, because remember, if you want an expression that's in simplest form, it has to have no parentheses. Well, the 2 is being multiplied by the group, so I can distribute it, meaning multiply the 2 times the 4, and the 2 times the t. 2 times 4 is 8, and 8 plus 2t. Now we have to ask ourselves, can we combine those? Are those like terms? Do they have exactly the same letter and exponents? And the answer is no. So this has no like terms, so it's already simplified. Next one over here, we have a 5 being multiplied by the group, so I will distribute it. 5 times g is 5g. 5 times 9 is 45. Are these like terms? Do they have exactly the same variable with exponents? And the answer is no. So those are already simplified. So now we'll do 4 of these examples. We'll do a lot of simplifying, collecting like terms, and distributing. So let's get started. 13m plus m. Now remember, what number is in front of the m when there's no number there? There's a 1. So think of this as 13m plus 1m, or 13 pencils plus 1 pencil. What do you get? You get 14 pencils, or in this case 14m. Those are like terms, and they can be added together. Here I can't have parentheses, so I will distribute. So 3x plus 6x. 3 times 2 is 6. That's how I got that. Now we notice that they are like terms because they both have an x. So you're going to add the coefficients. 3x plus 6x will give me a 9x. Over here there are no parentheses, and there are no like terms. These are a squareds, these are b squareds, so there's really nothing I can simplify. So we write the word simplified to show that it's already done. There's nothing else I can do. And over here, distribute the 4. 4 times 3g is 12g, and 4 times 2 is 8. These are not like terms because one of them is a number, the other one is a g, so it's already simplified.